Next, let's have a look at writing the most basic code possible for communicating with our device I/O. Remember, we're dealing with the Edison here. This is a system on a chip that allows us to write high-level code, so our goal is to learn what's going on under the covers, but then work our way up the stack until we can get out of the minutia and write in JavaScript. So let's start at the bottom. Now remember that SoC IoT devices are a main processor bridged to a microcontroller. Now as far as the code you write, that should all be abstracted away from you. In fact, there's a library on pretty much every IoT device I've encountered that does exactly that. It's usually written in low-level C, and it either gives you a C library that you can call as an API to the microcontroller, or it gives you mappings in a higher-level language like JavaScript or Python, or hopefully it does both. That way you have the choice to go low-level and write C, or go high-level. Now in the Edison, that library is called libmraa. This library attempts to abstract away not only the complexities of the microcontroller on a single board, but on multiple boards. It supports Intel's own Edison and Galileo boards, as well as the popular Raspberry Pi and some others. This means that you could write a program against the MRAA API and move your code easily from one device to the other with virtually zero code changes. Let's take a look at a quick example of the MRAA library in use. This will hopefully help you to understand what's always going on under the covers. Then we'll quickly put C behind us and we'll use strictly JavaScript. Now this snippet of 8 lines of C code uses the MRAA library to simply read a pin value and print it to the screen every second. It'd be hard for me to get the whole C program on one screen for you, but this snippet would also require your basic include at the top as well as a main loop. Let's break it down. First, we initialize pin 6. This is the actual pin that you see on the Edison's Arduino dev board labeled with a 6. Next, we set that pin to be an input pin. Remember, these pins can each either be used for input or output, but we have to specify which, or at least we do when we're at this level. Next, we use an infinite loop and the fprintf statement to read the pin's value and print it to the screen. The sleep 1 indicates that this will happen every second. Finally, we close our access to that pin when we're done reading from it. Now, I do realize that this line is not going to be executed since we'll be stuck in the infinite loop the whole time, but I wanted to leave it there from Intel's example so you can see that it is necessary to manage your pin access by closing it out when you're done with it. Well, that was fun. Now, the best way to get your hands on the libmraa library is by going to GitHub to the Intel IoT DevKit MRAA repository. Perhaps like me, though, you don't find much reason to dive down to the C level to get your work done. It's a bit geeky and fun to do so, but I spend most of my days in more abstract code. So let's go ahead and climb back up the stack. Now, conveniently, the MRAA library contains not only the C++ code, but bindings to JavaScript and Python as well. It's actually all right there in the same GitHub repository. So now let's take a look at the JavaScript API with a really simple example. Now, at first glance, looking at this code, you may notice that this is not much shorter than the C example that we were just looking at. That won't normally be the case, except in painfully simple scenarios like this one. Additionally, this is not just a snippet of JavaScript. This is the entire Node.js file necessary to do exactly what we did a minute ago using C. Read pin 6 and print the output to the screen every second. First, we import the MRAA module using require. Now, if you're brand new to Node.js, you'll actually get pretty far just knowing this one concept. When you need a third-party module, you require it. Usually, when you require a module, you also have to install it using npm, but MRAA is already installed globally on the Edison, so you can get by with just this require statement. Next, we instantiate pin 6 using MRAA's GPIO function. Next, we set the direction for pin 6. Note that at this level, using the MRAA library directly, even through JavaScript, we're still having to set the pin direction. Now, that might feel like busy work to you like it does to me, and thankfully that chore is going to go away later when we start using a good library. You'll see. Finally, we read the pin, write the value to the console, and set that to have happen every second using the common setTimeout JavaScript function. Note that we didn't have to close access to the pin now. Now keep in mind that later in this course we're going to introduce some libraries that will make even the hoops that we jumped through here unnecessary. I hope you feel, though, like you understand what it is that happens exactly at the lowest level. But I hope that you also feel encouraged by the fact that you aren't going to have to go through all that ceremony every time. All right, so now that we've written some basic code, let's take a look at actually getting that code out to the device so we can see it work.